Okay. Please don't think I'm saying when I tell you how you might have approached this on your homework or saying anything derogatory. Okay. Don't take it that way. I'm trying to coach you on how to approach homework and the things that you really ought to be doing. Okay. Because you had a problem almost exactly like this, the different numbers, and most people got it right. Most people got 100% on it, and most people had high scores on the homework. Okay, but nobody was able to get more than three of these. Okay, now three isn't terrible, but it's not really good either. Okay, it's like barely passed. Okay, one person got two, and another person got one of them. So there's some insight there, but nearly half the class didn't get any. All right. So this was the quiz. Now, I then asked you to state the rule for each of these. Okay. And when I look at it, most of you didn't get much of it. Okay. Some people came very close, but it was not the majority. So the point I want to make is, how many of you in your notebook have written down those rules for review and for reference? I'd say nobody, because people don't do that sort of thing, except for the people who excel in their courses. Okay? So that's the sort of thing that ought to be automatic for you to do. But of course, if you just came out of high school or haven't had a college level math course, I doubt if anybody's ever suggested you ever do such a thing. Okay? Now, when I say I doubt, I think there are teachers out there who would. I know teachers out there who I think would, or they do something equivalent. Okay? But you probably didn't have those teachers, because I only know a few teachers. Okay? And they're the ones that teach our dual enrollment courses. Okay. So, and if they didn't, hopefully they did something equivalent to help coach you on how to learn mathematics. Because it's not, you're not doing it effectively. Okay. And it's obvious just from the pattern. I went over all the homework, earlier this morning, both this course and the pre-calculus. It's obvious that people are doing something. Okay. But I'm afraid a lot of it might be doing it while you're looking at how to solve it, rather than figuring out how to do it after you've looked at the videos and so forth. Okay. So that's not effective. It's a start. So I'm glad if that's what you're doing, I'm glad you're doing that much. And I'm glad you're getting decent results. Now, it's also possible to get decent results by looking it up on the internet, looking at the answers without ever thinking about the question. I kind of doubt that any of you are doing that, but it's possible somebody is. Okay. So, that's a sure way to fail. Okay. Everybody in here has demonstrated at one time or another a decent aptitude that's consistent with being able to pass a pre-calculus. Okay. But you have to follow up the aptitude with, first of all, rigorously honest work. And by honest, I don't mean honest with me. If you're not honest with me, it's going to show up on the exams and you're going to fail the course. Okay. But if you're not honest with yourself, you're selling yourself short. Maybe life doesn't allow you to be honest with yourself. Well, I think that life does. Maybe life doesn't allow you to get everything done if you're being honest with yourself, but at least do the stuff as honestly as possible. And I think you try to do that, but I'm trying to point out what it means to do that. Okay. If you're being honest with yourself, you're gonna, on the problems that don't have videos and stuff, you're gonna put all your stuff away and you're gonna work out problems based on what you already know. And you're gonna write things down. You know, you're going to write down a note on how you approach each problem. Okay. And I'm going to probably ask you to start doing that. Just a note, how did you see this problem? How did you perceive it? What were your thoughts? Just a sentence or two. And I'm probably going to ask you to start submitting that or having it in your notebook, something like that. Okay. And that's not punitive or anything. It's just, I'm trying to pull you into the mode you need in order to be successful in college level math. Okay. And some of you are much closer to it than others. But performance in the homework has never been reflected in class on similar problems that I asked as a quiz. Okay. For most of them. Okay. And it's your job to find a way to make that happen. So I'm just giving you suggestions. Number one, be honest with yourself. Number two, write things out in some detail. Articulate in words what it is you're thinking. And make a list of the important points. Okay? If you don't have a list of these rules, then you're not doing what you really need to be doing. Almost everybody should have a list of these rules unless you already know them. And some people are pretty close. Okay? But don't rely on your memory. Even if you know them now, you're going to know them a month from now when you need them. Have them in your notebook for reference. Organize it somehow. Make sense? All right. So, okay. Now, I don't want you to look around, so look straight forward and don't see what anybody else is doing. But I want a thumbs up or thumbs down on each of these, okay? And it's going to have to be quick, so we only use whole class time going through this one exercise. So we're looking at the graph of f of x plus 7, right? First of all, tell me, put your thumb in a neutral position right now, and you're going to flip it up or down. Okay? Is this rule that applies? Down if no, up if yes. Okay, so you're pretty slow. That'll be instant. Okay? But I'll give you a little more than an instant because you probably still have to think about it. I'm not going to give you as long as I just gave you. Okay? You want to think about it. You want to think about which rule this is. You actually want to look down this list and see which one you think it is. Or if it's even there. Okay. What about this one? Okay. Are your thumbs stuck in the down position or did you mean down? Okay. Go back to neutral so I see them move. But yes, I know that's not it. What about this one? Okay. Well, this isn't it. But a couple of you thought maybe it was. But notice that x is not multiplied by anything, and here x is being multiplied by whatever c is. Okay? So you want to be sure you understand that. And what about this one? Yeah, that's pretty clear. And this one, that's pretty clear, right? Okay. It wasn't there. So what rule should I have had there? Somebody want to tell me what I should have written if I wanted to include that rule? Because naturally I left the easiest one out. Okay. Now most people have one variation or another on x, f of x minus h. Now some of you have plus. If you had x with a letter here and a plus or a minus, it's more or less okay, but this is the way it's stated. It's stated with h. Okay. What letter is this one stated with? Want to tell me? Show me? Okay, that's okay. We'll get to it. I'll comment when we get to it. Okay, so let's look at this one. Okay. Can you spot which rule it is? Now I'm going to ask you to show me figures. 1, 2, 3, 4, or 5. It's not this one we've already used. Okay. So we'll just do 1 through 5. So quickly, which rule? Yeah. Okay. See? That's pretty good. Okay. I haven't asked you what the rule is. Talk about what the rule is in a minute. Excuse me. one's this. Okay, a few books, 4 books, to give a couple more. Okay. Excuse me. That was there. Um, so it's number one. Is you have a number multiplied by f of x. All right. What about f of negative x? Well, that's kind of a no-brainer. It's this one. And what about negative f of x? Well, that's this, right? Okay. Okay, well, I'm going to do kind of in the order I think I reproduced f of x minus a. I stated it last time, you shift h units in the horizontal direction. Okay. I could say shift h units in the x direction, but x isn't always your variable. So I'll say in the horizontal direction. I think everybody knows what that means. And if you're drawing arrows, you know, it's like it shifts it in the direction opposite h. So you could maybe use an arrow like that if you understand what I mean, but if you don't, leave it alone. Okay. Now, the way the notation your book uses, they use a K. Okay, or I use a B, but it's the same thing. Okay. So, what's that do? Shift K units vertically. That would be up or down. Up if K is positive, down if K is negative. It should be clear why. Because f of x is the value of the function, and you're adding k to the value of the function. If you add k to the coordinates of a point, if you move the point k units vertically, it's going to add k to the y coordinate. It's the y coordinate that moves vertically. You want to understand that. Okay. And then I think the book uses a for this one. A f of x. I didn't finish my word shift here. Okay. So what that does is stretch. And the book doesn't state it exactly like I do, but I like a little precise statement. They say stretch it, stretch A. Okay, well, you stretch vertically A means you stretch vertically by a factor of A, means you multiply your vertical coordinate by A. Okay? Multiply your vertical coordinate by A. And then f of cx that we haven't talked about, and we're not going to talk that much about it until it becomes applicable or important. And that doesn't occur till late October or November, early November. Okay? So I don't want to confuse you with this. But the rule is press horizontally by factor C. Now, f of negative x you flip about the vertical axis. And negative f of x you flip about the horizontal axis. Right? Now, on your in your notebook, work the quiz again. So, do I hit that thing to bury it? Okay, so what we're going to do is we're going to see if we can apply each of these rules. According. So let's just take them one at a time. Make sure that you actually do this. Oh, come on. Oh. Okay, there we go. Okay, thank you. Okay, so okay, so shift. I'm going to write the word horizontal because a lot of you are mixing up vertical and horizontal. So notice I've got the word vertical or horizontal in every one of these. Okay, that's critical. You need to focus on that and you need to practice and get used to the rules until they make sense. That's how you learn and that's how you achieve not just barely passing grades, but good grades. Okay, and how you learn things that are going to be beneficial to you later instead of learning it long enough to pass the test so you can forget it. Because you're going to see it again if you're in the curriculum super part of this course. Okay. F of x minus a for shift horizontally. Is h equal to what? What's h equal to? Here, show me with your fingers. Okay, we don't have enough fingers, but h is negative 7, not 7. It's x minus h with h equal to negative 7. Okay. So we shift left 7. Why left? Because first of all, right and left are horizontal. And its rule is horizontal. And it's x that we're messing with here. Well, okay, so we shift left 7. And why left? Because h is negative. So that's in the negative direction. So that seven, negative 3, you're going to shift left. So you're going to shift left 7 units. That means you're going to subtract 7 from the x coordinate because it's horizontal. And so you need to digest all of that. Okay. Now 7f of x. This is a f of x. It's a vertical stretch. Okay. What does that mean? Okay. Stretch vertically by factor a. Factor means you multiply because it's a multiplication. Now, what is it you're multiplying? You're going to multiply X or Y. Okay, show me X or Y. Okay, well, didn't get a vote from everybody. But what's the rule say? Stretch vertically. What's a vertical direction? It's the Y direction. So you're going to multiply your Y coordinate by 7. That is, if you really understand this, and you need to work on it till you do, it's common sense because f of X is the value of Y, isn't it? Now that's something you need to understand. You got X and you got f of X. You solve problems involving that. You've stated solutions involving that. Okay. So that's something you really need to understand, because some people might be a little vague on it. All right. Now, I was taking a high-powered calculus course, and I hadn't had a pre-calculus course, and I'd never seen f of X notation. So remember, it took me a while, a couple of days, to get used to the fact that f of X is the Y value. So if it takes you a little while to get used to it, okay, but get used to it one way or another. Okay, you've seen it. You've answered questions, but hopefully you've answered them by figuring it out from what you'd already seen rather than looking at the answer and mimicking it. Okay? Again, look at the answer and mimic it as a step. But you have to move away from that because you're not going to have an example to mimic when you take a test. And you don't learn the stuff if you have to mimic. Okay? Mimicking can be a good step in learning, but you got to go beyond that step. And that's what we got to do with the idea that a point on the graph is here's the point. Here's your value of X. Y is the value of that value of X. So this point is X f of X. Some kind of stuff might have to come out for a month. So that okay. I think I'd have better control of chalk by now, but sometimes it's bored to believe it. Okay. So the coordinates of this point are X, Y, but you can write that X f of X if you've got a function. You have to graph with the function. Digest that. Okay. So all that goes together into understanding is 7 f of X means you multiply f of X, which is your Y value, by 7. So multiply Y by 7. Because Y equals f of X. Okay? And you're multiplying f of X by 7. So 7 negative 3 transforms to the point 7. 7 times negative 3, which is 7 negative 21. Now I skip f of X plus 7, so let's do f of X plus 7. The rule is f of X plus K. K is outside the parentheses. F of X is just what it is. In this case, f of X is negative 3. Okay? So if vertically K units. You add k to the y value. And 7 negative 3 becomes 7 plus negative 3, which is 7, 4. A lot of you got this. A lot of you got, multiple people got each one of these, but nobody got them all. Okay? Mostly, especially on the ones that people got more of them, there's a lot of confusion between vertical and horizontal. Okay? And that takes some sorting out. So it's sorted out. I don't think the 7 is visible in this one, but okay. All right, well, then we got f negative x and negative f of x. The rule is this. It's flip or reflect about the y-axis. Now, if you flip about the y-axis, the point is going to move horizontally. Of course, the y-axis here, it points to this side, it's going to move over here. It's going to move horizontally. Yet if your point is over here, it's going to move over here, equal distance on the other side. This changes the x coordinates of 3, oh, sorry, 7 negative 3 goes to negative 7. Negative. Okay. It's like you're down here. Negative 7, negative 3 might be here, over here. So that might even be it. Okay. I'm sorry, 7 negative 3 might be here, and it would move this way. We started with 7 negative 3. And then negative f of x. So f of x is y. That tells you right away that y is going to change sign. You got to take the negative of your y coordinate because f of x is your y coordinate. But again, that involves having sorted out a number of things. Okay, so negative f of x. We're going to flip vertically. Why? Because you draw a picture of a point anywhere you want except on the x-axis, and you flip it, it's going to move. Flip it around the x-axis, you're flipping this way, it's going to move here. Okay? So have to put all that together. And it's a good chunk. All right, in any case, so we flip vertically. Multiply y by negative 1. So that's 7 negative 3 goes to 7 3. And it looks like this. 7 negative 3 in the fourth quadrant. You flip it, you go to the first quadrant. Okay, so these rules, you need to think about them until they're really obvious. It says f of negative x. Doesn't that tell you to multiply x by negative 1? Change the sign of x? You replace x by negative x. That's what this does. And that's why it flips it horizontal. And as I said, this is your Y value. You change its sign, you flip it then from above the x-axis to below, or from below to above, depending on which side of the x-axis the point is on. Okay, it's got a vertical. Okay, now you really should understand everything that I've said here. Now, this is a companion course for pre-calculus. You're going to be much better off if you understand it now, okay, where you might have already seen it in your pre-calculus course. Hopefully this clarifies it. So if you haven't seen it, you're going to see it, and then you should understand it much better when you do. If you're in my class, I think it's assigned for someday next week, okay? Maybe even for Tuesday, I don't know. Yeah. I don't have the schedule in front of me, and it's all jumbled between the two courses, so I don't always have it in mind. But I'd look at it right before class to make sure I'm oriented. I've also got notes here in my pocket about what I'm supposed to do today. Okay, I haven't taken it out of my pocket because a lot of times what I see on the quiz dictates what I'm going to do, and whatever I thought I was going to do goes out the window. Okay, because it's what I need. So, I've always got a plan. Don't follow because of what I'm seeing. Okay, so what I'm seeing is this really important stuff because this brings together just a whole lot of stuff that we've seen so far. Okay. Do your best to understand this as well as you can. Use the problems for practice. Go to the Have Credit site, use those problems for practice. Find problems about transformation. Go look at your text. It has problems at the end of the chapter. Okay. You have lots of opportunities for practice. And then write stuff out in your notebook. And if you're having trouble with it, make a note of where it is so you can find it quickly in class and ask me a question. Don't say, hey, I've got a question. Then spend 5 minutes flipping through your notebook to find it, right? Because we can't waste class time. Not that I mind giving you extra 5 minutes if I had it to give. I've got a lot of stuff to do, just like everybody, right? And most of it's, benefit my students. So be organized. And hopefully take a lesson from the things I've recommended you do in the learning process. Okay. This is another example. There's a calculus course in the future. You don't want to make a C in this course, although if you make a C, you can get through. Okay. But you're going to have to work a lot harder, and you're not going to do as well in calculus. Problem people have is they never really learned what they learned in elementary school, and then they never really learned what they learned in middle school. Then they never really learned what they learned in high school, and now you got to know it all. Okay? You're going to be in that position with the calculus course. And the better you can learn this course, not everybody's going to be capable in the time they have, depending on their background and the time they have to spend on it. Not everybody's going to make an A in their pre-calculus course. If you make a high C, it's not too bad. But if you make an A or a B in your pre-calculus, you'll be much better prepared for calculus. Okay. Another thing is high school grades don't really necessarily mean anything because everybody has to have an A. There are way too many A's. Okay. There's no standard. So your smartest people come out not learning half of what they need to know. And if you're going to compete with the smartest people, and not everybody's going to, not every curriculum forces you to compete with the smartest people. Engineering kind of does, but most other curricula, you're competing with smart people. You're not trying to compete with the very top. Although, if you're the very top, then be there. Okay, that makes sense. You're still going to be competing with good people in any degree. All right. there are two assignments that are going to be due for next week, or for next Tuesday. One of them is just on negative exponents and zero exponents, which is a review of Algebra 1. So I'm not going to talk about it. But if I find that you can't do it in class, well, then we're going to have to take a chunk of time in class to get that right. So learn it. I'd like to see you learn that really well and properly so that you can pass a simple quiz on those rules. Okay? And that's totally achievable. That's something that, ninth grade students do. Okay? A lot of times, eighth grade. Not that people aren't pretty smart by the time you get to eighth and ninth grade. Okay, so could I add a rule? Fit right in with the other rules that I just flipped over on the other side of the board because we don't really have to refer to them. Since you've already kind of got them in your head, know what they are, hopefully written down. And if you haven't written it down, just do it later. Okay. And make sure you write them in a way that makes sense to you, but also compare with the way I've written them down because it's succinct and it's definitive. Okay. Could be more succinct and more definitive. It's about the level that you need to understand. Okay. Okay, so now the -1 exponent often means reciprocal. Okay. This doesn't mean reciprocal. It's not really an exponent, it's part of the function notation. Okay. So -1 isn't an exponent. F inverse we read this as F inverse, and F inverse isn't the reciprocal of F. I mean, actually, in one case it is. If F is a reciprocal function, well, and F inverse is the reciprocal of F, but only for that function, not for any other. So what I mean by F inverse, if Fy is a point graph of Y equals F of X, then Yx is on the graph of Y equals F inverse of X. Okay. That's the definition of an inverse function. Now it's pretty easy to do the inverse function for a graph. And I'm not going to talk about that right now because the thing's going to give you trouble is getting the formula for an inverse function. Okay. So that y equal f of x equals 2x minus 5. Then f inverse of x satisfies x equals 2y minus 5. Why? Because you're switching x and y. I can say down here, we switch the x and the y coordinates, okay? So we get, instead of y equals 2x minus 5, we get x equals 2y minus 5, okay? We solve for y. Now, how do you solve this equation for y? Well, you have x equals 2y minus 5. We're trying to isolate y. We have to do it using the rules of algebra, which allow us to add the same thing or subtract the same thing on both sides. So I'm going to add 5. We're just solving a linear equation. And if you don't remember how to solve linear equations, we've been doing a lot of that in the MDE 60. You go to the main assignments page and you can click on the MDE 60 page, okay? And you get plenty of review on how to solve linear equations. But this should be something that's hopefully familiar to you. If it is, you're going to have to dig a little bit, okay? And that's a good place to dig. There are other places, just look it up on the internet. You get a billion videos and explanations of how to solve linear equations. Plenty of examples, and they all say the same thing. Okay? So you use my videos, you use somebody else's videos, whatever works for you. You don't hurt my feelings if you use somebody else's video. You just hurt my feelings if you don't learn. Okay? Now, of course, this gives you x plus 5 equals 2y because negative 5 plus 5 is 0. Okay? Now, the thing we're solving for, we usually like to have one for that. It's just kind of convention, and it looks better and feels better, and avoids potential confusion. Okay? So you get your variable on the left, and then you want to get y by multiplying, dividing, adding, or subtracting both sides, same number. So we divide both sides by 2. Well, then this 2 divides this 2, because this 2 is multiplied by the rest of the numerator. And it gives us y equals x plus 5 over 2. Well, that's perfectly good. Okay. Now there's something I've got to look at on the order of assignments, because something I'm not sure got assigned before we did the inverse functions.